Okay, guys, so now we're into module 6. Kind of seems like going backwards in these numbers sometimes, but it is what it is. Hopefully you've already you've already done the pre-test. Remember, the pre-test is not something that affects your overall grade. It's just a matter of how much do you know before you learn anything. So chances are you probably don't know a whole lot, but it is what it is. It's a pre-test. Make sure you take it. And then hop on over to this video. And if you're already taking it, then just stay here. All right, so in this chapter, we're learning about statistics. This is going to be a much better module for a lot of you guys than the quadratics. Quadratics are one of the toughest things to do. So statistics is a nice sort of way to end the year a little bit. They're not as challenging as the quadratic stuff can be. So you can read this for yourself. It just talks about kind of certain statistics obtained from the 2012 Super Bowl. But what I want to get into are more the mathy things. So the statistical process is basically a science brought to math. So in science, you guys would probably do experiments where you plan the experiment, you conduct the experiment, and then you look at the results and you analyze the results. What do the results mean? What happened in the experiment? What is the conclusion? Statistics is just like that, but with math. So for statistics, you'd make a plan, then you would go out and record data. You're not really doing an experiment, but it is sort of an experiment. You're recording a certain amount of data, like how many different brands of toilet paper are still on the shelves. There's 5 of this brand, there's 7 of this brand, there's none of this brand, right? You're collecting data about what's out there. And then you take all that data, you analyze it, and you interpret what does it mean. So if you have, 7 rolls of toilet paper or packs of toilet paper for one brand and 0 of the other, maybe you can interpret the fact that one brand makes a lot more, or maybe you can interpret that one brand is more popular and sells out quicker than the other. There's several things to consider, but you still would look at the results and try to understand what they mean. Okay. So you form a question, design a plan, and then you attempt it. Now, there are 2 types of data that you need to keep in mind. And that's categorical and quantitative data. Categorical data is things that can be broken into groups, into categories, like favorite sports or favorite color or eye color. I like to think of color a lot, but things that can be categorized. Quantitative data is things that are more numerical, like heights, percentages, things that you would measure, distances maybe, things that can be broken into ranges of values. So, for example, this one says free throw percentage. It looks like, free throw percentage. So 45 to 55%, 56 to 65%, right? So on free throw percentage. So that's more quantitative. Now, what's going to come up later in the section is bar graphs and histograms, and we're going to come back to this type of data. Bar graphs will use categorical data, and histograms will use quantitative data. And they look very similar. They're both, bar graphs and histograms. People confuse them a lot of the time. They think they're the same thing, but they're not. And I'll explain those differences later. And one of the main differences between them is, like I said, bar graphs will use categorical data where you have your categories, whereas histograms will use quantitative data where you have ranges of values. That's going to be the main difference between them when we get to them. Let's move on to page 3, where we talk about dot plots, I think. Yes, dot plots. Dot plots are a very easy thing to understand. This all explains it, but I'll just do it with this video. So for this example, Wesley's class, he's collected data on how many dandelions can be found inside the area of one hula hoop, apparently. So all the groups threw their hoop and they collected their data. So one group had 9 dandelions inside their hula hoop. Another group had 10 dandelions. Another group had 11 dandelions, right? So you get the idea. They've recorded how many dandelions are inside each hula hoop. So they listed them out, and they listed them out in numerical order here. So what we notice is that only one hula hoop had 8 dandelions in it. So if you look at the histogram, you'll see that there's only one dot above the 8 to indicate one hula hoop had 8 dandelions. There were 2 hula hoops that each had 9 dandelions in it. So on the dot plot, you'll see that on the number 9, there are 2 dots above it. Makes sense? There were 4 hula hoops that had 10 dandelions in them. So for the value 10, you can see that there are 4 dots above it to indicate the 4 hula hoops. There were 2 hula hoops that had 11, so you see 2 dots above 11, and then 1 of 12, 1 of 13. So that's what a dot plot is. It's simply the number of dots. It's kind of like a tally measure in a way, but it's kind of like taking tally marks in a bar graph at the same time to make it look good. So here again, just to kind of talk you through it. So for blue, if this was about people's favorite color, 4 people's favorite color was blue. So you can see that blue on our line here has 4 dots above it. 2 people had green as their favorite, so you got 2 dots above green, right? 2 people thought red was their favorite, so you got 2 dots above red. Purple is the most popular, of course. It's got 5 dots, which means 5 people picked it, and then black has 2 dots, meaning 2 people picked it. So it's pretty simple. It's just kind of more of a visual representation of the table. So if we want to make one, let's try to make this one. So let me snip this, and we'll work this one out together. So we have our values. There's a lot of them. So first we learned that the resting heart rate is between 60 and 100 beats per minute. He decided to record the average heart rate of people over 5 minutes. So let's find out our results. So let's see, I've got 68. How many 68s do I have? I wonder if this breaks it into categories or if it breaks it into ranges. I actually want to check that real quick because I don't want to do it differently than they do it. Okay, so they made a whole number line thing. That's fine. They could have done it in ranges, but that's fine. So 68. How many people had 68? I got 1, and then I'm checking down the list here to see if there's any more. It looks like there's another one. So there's 2. Checking down the list, and there's 3. So it looks like 3 people had 68. So I'm going to make a note of that, right? 68. We had 3 people. So let's cross them all out so that we don't mistakenly pick them later. So 68, 68. So what's another number? We've got 72. So we have 172. We have 272. We've got 372. So we'll cross those all off as well. So 72. We have 3 people. Let's do 78. So we got 1, 2. Looks like just 2 for 78. Cross them off again. So for 78, we had 2 people. 80. Let's see how many people had 80. We had 1, 2, 3. So 3 people with 80. So 80 again is 3. Let's see, 69. So we had just 1 right there. So 69, just 1 person. So that's all those numbers. We don't have to worry about those. So 89. 89, we have 1, 2. We have 2 people with 89. So 89, we had 2 people. 60, let me cross them off. 62, we only had 1 person at 62. Let's see, 75. We have 2 people at 75. And then, of course, we can see that 1 person at 76 and 2 people at 70. All right, so when you make a dot plot, let's see, how can I do this? Do I have room for this somewhere? I'll just make it kind of small. But you would make your number line. We'd have our number line. And then let's put these in order. So let's start at 62. Let's see, 62, 68, 69. 70, 72, 78, 70, 72, 78. Oh, well, we skipped a few. Let's do 72, 75, 76, 75, 76, 78. See, I got this one, 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 this one. Okay, so then just 80 and 89 at the end. 80, 89. So 62 had one person, right? So there would only be one dot above 62. 68 had three people, so there would be three dots above 68. 69 had one person, so one dot above 69. 70 had two people, so two dots above 70. 72 had three people, so three dots above 72. 75 has two people, so two dots there. 76 has one person, so one dot above it. You get the idea, right? That's how a dot plot is made. I'm not going to finish it because I ran out of room, and I don't want to make the video too long, but you get the general idea. And of course, it's all graphed here for you, so you can see the results as well. All right, let's look at page 4. So bar graphs and histograms, as I was mentioning earlier. So remember, bar graphs are going to focus on categories. Histograms are going to focus on numerical data and ranges of data, okay? So for a bar graph, here in this bar graph, we have our categories being fruits. So we have orange, apples, blueberries, bananas, strawberries. And then we have the value, the number of people who chose that as their favorite fruit. So for oranges, you can see on the bar graph, that bar goes up to 40 since 40 people liked oranges. Apples, the bar goes up to 50 since 50 people liked oranges. For blueberry, it went up to 35, and you get the idea, right? It's just a bar graph. But it makes it easy to see the data. We can see just by looking at the bar graph that apples is the most popular, and blueberries, well, not blueberries, but strawberries seem to be the least popular. So if we were to make a bar graph of this, I can probably manage to squeeze it on, make it on the screen. So we have our categories. Our categories are biggest fear. So let's see, we have people who are afraid of spiders. We have people who are afraid of snakes. Public speaking, I'll just put PS. Flying and the dark. So we have 12 people are afraid of snakes. Oh, it says 18 people. This is weird. 18 people said their biggest fear is spiders. So if we do this by like 5, maybe 5, 10, 15, 20, 25. 18 people are afraid of spiders. So the bar for spiders would go up to about 18. Snakes, you've got 12 people were scared of snakes. So its bar would go up to about 12. Public speaking, you have 25, so that bar is going to go really high. It's going to go all the way up to 25. Obviously, I'm just kind of making a sketch, but you guys kind of get the idea, right? 9 for flying, and then 14 for dark. So dark go up to about 14. So you have your bar graph, right? Simple enough to do. I think most of us can make bar graphs. Histograms, though, are kind of a new thing for us. So let me show you. I'll let you guys kind of, listen to this example. But what I really want to do is I want to work this one out for you. So a survey of 20 people were conducted, and the following table shows their heights. I'm going to go to my whiteboard for this because I don't see enough room to write on the screen. So let's copy our data. We have 60 to 63. We had 4 people. From 63 to 66, we had 6 people. from 66 to 69, we had 8 people. And from 69 to 72, we had 2 people. So how a histogram looks is it's like a bar graph, right? But it's just a little different. So on the bottom of our histogram, our graph, will be our category ranges. So since we're going from 60 to 72, let's say we've got 60 here, 63 here, 66 here, 69 here, and 72 here. So let's number these off. Let's go by twos. 2, 4, 6, 8, 10. And then the little hash marks are the odd numbers. All right, so 60 to 63 had 4 people in it. So from 60 to 63, you're going to make a bar that goes up to 4. Okay? So just like a bar graph, right? But you can see it's including the range 60 to 63. 63 to 66, there are 6 people. So that bar from 63 to 66 goes up to 6 people high. Now, it's a very important feature here. You'll notice that the bars are touching each other here. The bars are, there's no space between the bars. And there can't be. A histogram, if you want to make a quick note of this, histograms have no space, okay, between bars, okay? And that's very important because otherwise it's a bar graph and bar graphs are wrong. The reason there's no space is because we're going straight from 60 to 63 to 63 to 66. There's no gap when you're talking about heights. It's those numbers all sync together. So there's no gaps between it. The only reason you'd see a gap between histograms is if there were 0 people in that category. Like, for example, if 66 to 69 had 0 people, then the bar there would essentially not exist in this region. So that would be a gap. But that's the only time you'll see a gap in histogram is if there's a bar that's technically 0 high. Otherwise, all the bars touch each other. So 69, 68, 66 to 69 goes 8 people tall. So we're going to have 8 people from 66 to 69, and then 2 people from 69 to 72. And there's your histogram. No space between the bars, and you're going from over ranges of values. It's very important, but it's pretty much a bar graph. But remember the difference between this and a bar graph is a bar graph has categories. Histograms will not. Histograms have the ranges. So let's look at another example to get kind of an idea. Also, let's see how this one worked, just to make sure the answers look good. And yeah, see, so theirs is pretty much the same as mine, which is awesome. So let's try example number 2. So we have our ranges 1100 to 1400. Let me write these down. 1100 to 1400. Then we had 1401 to 1700, 1701 to 2000. Let me see what other branches. Then you got 2001 to 2300. So for the number of, is it people? What are we talking about here? The SAT scores. Yeah, so the number of people were certain SAT scores. So we got 34, 65, 48, and 20. So we got 34, 65, 48, and 20. So that's the number of people that scored in that particular range on the SAT. So 34 people scored between 1100 and 1400. 65 people scored between 1401 and 1700. Right? You get the idea. So for our histogram, let's put our bar at the bottom. Let's put it at, I guess we'll start at 1100, right? And we'll just go the way it has it. So we'll go to 1400, and we'll go to 1700, 2000, and then 2300. So from 1100 to 1400, that range, we had 34 people. So let's go by maybe 10 to 10, 20, 30, 40, 50, 60, 70, 30, 40, 50, 60, and then all the way up there 70. So we had 34 people. So we'll have to go up to about 34, right about here, and we'll make our bar. Remember, that bar goes all the way from 1100 to 1400. It includes the entire range that's there, okay? So 1400 to 1700, there were 65 people. So 65, we have to go way up for this bar, way up there to 65. Remember, that bar goes, kind of missed it there, but all the way from 1400 to 1700. Then from 1700 to 2000, there's 48 people. So that bar is going to go up to 48, right about here. Again, kind of missed the mark, but it's all right. And then 20 in the last section. So 20 for 2000 and 2300. And there's your histogram. So again, it's just like a bar graph, but the bars are connected. There's no space between the bars. Okay, they go all the way around from their range. They fill in the gaps completely. So that's what the graph should look like. Exactly. Perfect. All right. So activity 1 is just asking if the data is categorical or quantitative. Remember, categorical is categories, groups, and then quantitative is numerical. So since the grades are categories, A, B, C's, and D's, they're not numerical, that would be categorical, right? So the next one, notice this is a range of values. A range of values is not categorical. A range of values is quantitative. So that one should be quantitative. And then last one, again, simple enough. You can see that this is genre. This is categories. These are not ranges of values. So this is more categorical again. So not too tricky. Activity 2, what is this asking us to do? The following table shows the results of top 5 women's 100-meter breaststroke times for the 2012 London Summer Olympics. All right. What type of graph would work best? So, given the fact that these times are not categorical, these times would fall into numerical quantities, right? Like a range of values, like swimmers that swim between a minute 5 and a minute 6, and then swimmers that swim between a minute 6 and a minute 7, right? You can break them into categories. You can, or not categories, you can break them into a range of values. So for example, I don't know what, I didn't read the full answer there, but for example, maybe you can say for these times, you can focus on the swimmers that swim between a minute 5 flat and a minute 5.5, right? And then maybe you can have the people who go from a minute 5.5 to a minute and 6 flat. I guess we'll put 0.0 there to make it even better. Then you can have people who swim a minute 6 flat to a minute 6.5, right? Minute 6.5. So you can have it into those ranges, right? A minute and 6 seconds 0.5 to a minute and 7 seconds flat, right? So you can break it into these ranges of values and you can make a histogram out of that. So how many swimmers swam between a minute 5 and a minute 5.5? Well, there's only one swimmer that swam in that range. How many swimmers swam between a minute and minute 5.5 to a minute 6? Minute 5.5 to a minute 6. There's only one swimmer in that range as well, right? A minute 6 to a minute 6.5. So that's only one person again. And then people that swam a minute 6.5 to a minute 7 seconds. There are two people in that range. So you would simply make a histogram for that. You know, that's best. But definitely you'd make a histogram because you would break this into a range of values. It's not categories. This is not categorical. If you're categorizing it by country, then yeah, sure. But we're not. We're categorizing it by swim time, and swim time is a numerical range of values. So you'd want to go with something like a histogram for it. Yeah, so this is exactly what I was just kind of working on. You have the times a minute 5 to minute 5.5, a minute 5.5 to minute 6, a minute 6 to minute 6.5, a minute 6.5 to minute 7. And the y values were one swimmer, one swimmer, one swimmer, and two swimmers. I believe that's the correct answer. Yes, and the difference between the first choice and the last choice is that the last choice here, these are not ranges of values. It's only a minute 5 even, a minute 5.5 even, a minute 6 even, and a minute 6.5 even. So I wouldn't want to go with that. I'd want to go with the range of values. So that's exactly what I showed you a second ago. All right, guys, I think you're ready for the quiz. If you have other questions, please leave them in the discussions tab. Good luck on the quiz. Hopefully it's not too challenging for you. Hopefully it's a little easier than the quadratic stuff. But yeah, like I said, if you're stuck on anything, just let us know. We'll be happy to help. See you in the next one. Goodbye.